Hey, hello friends, welcome. Hope all of you are doing good. If you are new, please consider subscribing to the channel and do like the video for YouTube propagation.
All right, so it's time to look at Ethereum and the core concept of Ethereum, which made Ethereum the number two blockchain in the world today. It's nothing but smart contracts. Now, it's very important to understand what is a smart contract. You can look at smart contract as a program that runs on the Ethereum blockchain. A program is nothing but a collection of code that resides at the Ethereum address on the Ethereum blockchain. Smart contracts are a type of Ethereum account. This means being an account, they have a balance and they can send transactions over the network. Let's look at what is a Ethereum account. So by definition, an Ethereum account is an account which holds Ether, right? It has a balance of Ether that can send transactions on the Ethereum blockchain. Accounts can be user controlled or deployed as smart contracts. Now let's look at types of accounts. There are two types of accounts: externally owned, which is nothing but controlled by anyone with a private key, and contract, which is nothing but a smart contract which can be deployed to the network and which is controlled by code. To create an account, there has to be certain principles, right? You have to have a certain steps that need to be followed. So whenever you want to create an account, the most libraries that generate will generate a random private key for you. A random private key means a private key which is 64 hexadecimal characters and which can be encrypted with a password. Now, example, you can see a private key like this, right? So it is nothing but a 64 hex characters long, which is encrypted. Let's understand the block diagram of an account. Okay, so when we are talking of an account and its block diagram, we need to understand how it is structured within the Ethereum blockchain. As I mentioned, it has an address, a 64 hexadecimal code address, right? And it is made up of four nodes. Now, each of the node has a unique significance. So for example, nonce, it is the counter that indicates the number of transactions sent from an account. The balance is nothing but the number of V owned by the address, right? The storage hash is sometimes known as a 256-bit hash of the root node, and code hash is nothing but the contract account which has the code fragment. Now remember, storage hash corresponds to account storage and code hash corresponds to EVM code. Now this block diagram is applicable to both types of accounts. Let's look at the key differences. So the key differences that we're talking about are between the private owned or the externally owned and a smart contract. So when it comes to private or externally owned, right, creating an account costs nothing. Anyone can create an account, anyone can initiate transactions. Transactions between externally owned accounts can only be ETH transfers. So this is very important. Since we are on the Ethereum blockchain, externally owned accounts can only do transactions on ETH level, which ETH is nothing but the cryptocurrency on Ethereum. Now, comparing an externally owned account with the smart contract. So here the key difference is a smart contract has a cost because you're using the network storage. Now, why is there a cost? Because a contract has code and code has to be stored somewhere. That's why the cost. Now, A contract can only send transactions in response to receiving a transaction. That means transactions from an external account to a contract or a contract account can trigger code within the contract which can execute many actions. Actions such as transfer of tokens. And these tokens can be not only ETH tokens but other tokens, or even creating a new contract. Now, the best example of a decentralized concept is basically a vending machine. Here, a vending machine, why is it a perfect example or a best metaphor? Because to get a snack from a vending machine, what there are two things required: money and snack selection. So there is no central authority required. You input money, you input your snack selection, and a snack is dispensed to you. The vending machine is a perfect example of decentralization. Now, if you're considering a digital vending machine, even better. You don't need a central authority to control your transaction. Now, let's look at certain advantages of a smart contract. Smart contract is permissionless. What does that mean? It means whenever you are creating a smart contract or the code which is within the smart contract is executed, you don't need anyone's permission to execute that code. It is automatically executed based on certain actions. Code is law. Now, here you can see 4 points. Basically, anyone can write a smart contract and deploy it to the network. All you would need is to learn how to code in a smart contract language and have enough ETH to be deployed. Basically, contract is an account. That's why you need ETH to store your code. Deploying a smart contract is technically a transaction. Now, this means since it is a transaction, it will have certain fees. These fees are paid by gas, which is ETH. ETH is nothing but the cryptocurrency on Ethereum blockchain. Now, in order to write a smart contract, Ethereum has many developer friendly languages, many of them. But I would focus, or I would say, there are two major languages which are very popular, right? The very first language is Solidity, and the second most famous is Viper. Since Solidity is the most user friendly language or the most famous user friendly language on Ethereum, let's look at a sample code or a sample contract in regards or with respect to the vending machine example that we saw. So here you can see a sample program with Solidity, and we'll see a contract written for vending machine. Now the contract will have certain code. Code is nothing but lines of information. These lines are written in parenthesis, which is the opening bracket. The code will have a body, right? So here you can see we are declaring certain variables for the code. First variable is the address. Any contract is an account, so it holds the address. Then we'll see a mapping function here, which is a public function, which is called cupcake balances. Now, this cupcake balances variable will have to be populated because you'll have to have certain balance for it in order to sell it. So we'll set a certain balance with constructor function. Now, constructor is basically, for my non-IT friends, constructor is a function which automatically triggers as soon as the contract is deployed. So constructor, and you can see cupcake balance is equal to 100. Let's not go into technical details, just how the program looks like. I wanted to show you guys. So here you can see cupcake balance is equal to 100. In the second line you can see that we are allowing the owner of the contract to basically refill the amount of cupcakes. So again there will be a function called refill. This refill function will allow the owner to increase the balance of cupcakes. Just remember the owner only can trigger this particular function. So your authorization concept is applied. Now We are allowing, second step, we are allowing anyone to purchase our cupcakes, and the purchasing price will be nothing but ETH, because we are deploying the smart contract on Ethereum network. So we'll define certain function called function purchase. This function will basically check two things. First, is the amount equal to 1 ETH? So we are charging 1 ETH for one cupcake. So first thing it will check is if you have paid exact amount for the cupcake. And second thing for it to check would be if there are enough stock available to sell. So once these two conditions are satisfied, then it is updating the amount of cupcake, and it is also sending the message to the sender with the exact amount. So this was a sample code just for your reference and information.